3.2, Law of Cosines. So what we're going to do now is we're going to use this law to solve triangles that are not right triangles. And in fact, we use the law of cosines to find a missing side if we know two sides and the angle between, or an angle if we know all three sides. So that's when you're going to use the cosine law. And it's a relationship. It says that the side length A squared is equal to B squared plus C squared minus 2BC times cos of A. This is the relationship that's super important. The side length squared, you have to put the cos of the angle directly across, okay? So sometimes they'll mix up the letters, but don't be scared, okay? So for instance, if I wanted to find B squared, I could put B squared here. What matters is that I have cos of, directly across from it, of B. And then here goes the other two side lengths in any order. I could go C squared plus A squared minus 2AC or 2CA. Okay, that's the relationship that's important. Okay, so when we solve these, we want to be able to do as much as we can in our calculator, because if we can do it in our calculator, then there's no rounding, we're not making any mistakes. So here we want to find x. We have two sides and the angle in between it. So I can say that x squared is equal to 8 squared plus 9 squared minus 2 times 8 times 9 times the cosine directly across from x is 130. Running out of space there. There's a 0 there. Okay? In our calculator, we want to enter all of this. We want to enter in our calculator x is equal to the square root, and then you want to bracket the heck out of this and enter it all in. So it just spits out the number. Okay? So depending on how your calculator works, most of your graphing calculators, you write cos first. Cody, who's using a regular calculator, is going to start here. You're going to go cos 130 times 9 times 8 times negative 2 plus 9 squared plus 8 squared equals, with your answer, you're going to do square root and pump out your answer. So I would, if I were you, take a second, grab a calculator, see if you can get this answer. X equals 30.22. Okay, here's another example where we're finding x. So here we have two sides and the included angle. So that same relationship again. X squared is equal to 24 squared plus 30 squared minus 2 times 24 times 30 times the cos of directly across from what we're trying to find, 67. Okay, x is going to equal the square root of that. So we want to enter it all in our calculator again, and we should get 30.22. I was looking on the wrong page for the last one. The real answer for this one was actually 15.41. So hopefully you guys aren't too frustrated that you couldn't get that one. 15.41. Okay? Here we're going to determine all the angles. So remember, if we have all three sides, we can use this cosine law to find the angles. First of all, we're going to decide which angle to start with. We're going to isolate that angle and use inverse to get the angle. So let's start with A. So if I were doing this, I know that I would have to look at the side directly across it. I would know that 5 squared is equal to these two sides, the sum of these two sides squared, 9 squared plus 12 squared minus 2 times 9 times 12 times the cos of A. Now I want to get cos of A all by itself. So what I'm going to do is I'm going to go 5 squared minus 9 squared minus 12 squared is equal to negative 2 times 9 times 12 times the cosine of A. Okay, I'm going to divide both sides by this, so I get cos A by itself. So I go 5 squared minus 9 squared minus 12 squared, all divided by negative 2 times 9 times 12 is equal to cos of A. So I've done this, I've isolated. Now I need to use inverse cosine to figure out what this is. So I would put all of this in my calculator with some beautiful brackets, and then I would write the cos to the minus 1 or the inverse cos to get my answer. And in this case, the answer should come out, we should get A to be 22.92 degrees. So 22.92 goes right there. Okay, we can do this thing again. We can go through the same process, and now we can get another angle. And then the third one, chances are we're just going to use the fact that the sum of the angles add up to 180. So let's do B next. So we're looking at this side across from it. So we know that 12 squared is equal to 5 squared plus 9 squared minus 2 times 5 times 9 times the cos of B. We're going to isolate that once again. So take a few seconds to isolate that, and we should get B is equal to 114.97. And finally, you can either go through the cosine law again or use the sum to get C to be 42.83. So when you have your printed out notes, I would take a second just to make sure you could do this in your calculator. Okay. Last example. Find the length of a diagonal in an isosceles trapezoid if the shorter base is 8 centimeters, each leg is 5 centimeters, and a base angle is 53. Give your answer to 2 decimal places. I gave you a little bit of a hint here. The same side interior angles are supplementary. So, same side are supplementary. 53, this is isosceles, so that means that these two angles are the same. This 53 is the same as this 53. Okay, and same side are supplementary. So 53 plus this angle add up to 180. So that makes that angle have to be 127. And again, because it was isosceles, this is also 127. So that was a missing piece of information there. So what we really want to find is the length of the diagonal. You can tell that's looking at this line right here. We can use the cosine law. We know that that length squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of the angle directly across from that side times the cosine of 127. Okay, entering this all into our calculator and square rooting this, you should get 11.71 centimeters. So again, print out these notes, double check you can do those calculations. If not, I'm more than happy to help you with your calculator.